Hi everyone, welcome to our demo video about the Cumulocity IoT trial experience. My name is Andina and together with my colleague Murat we are going to show you how easy the first steps of an IoT solution can be achieved. Let's think back on the late 90s or around 2000 before iPhones, smartphones or tablets. We had several devices, each with a specific task. We had a camera for taking photos, had probably a Game Boy for playing during a journey. We had calculators, watches, Walkmans, many devices in our pockets. There was basically no cross-functionality. If I needed the time while playing Game Boy, I had to check my watch. If I needed to check my free time while calling somebody, I had to open my calendar. The same is true nowadays for the most of the IT landscapes in production or industry. There are multiple systems and every single one is responsible for one particular task. Today we want to guide you through how IT landscape and how we work can change and improve while using an IoT platform.
In the next 30 minutes, we want to guide you through the first and also the big picture steps of how an IoT platform can help to improve your daily life and work. We will start with showing you how an own tenant can be created with just a few clicks and also how to get your first connected devices within minutes. After that, we want to demonstrate how simple customized dashboards can be created via drag and drop. Creating powerful analytics rules will be the next topic. Here we are going to show you a non-coding application for everybody. To analyze historic data is very important because you can gain many insights. So we will demonstrate you how an easy-to-use data pipeline can be built up, which then leads to machine learning use cases which usually are very hard to achieve. In that chapter we are going to guide you through the first steps for a training process. And last but not least, integration plays a major role to get a more cross-functional view. How self-service integration can look like will be shown in this chapter.
With the Cumulocity, everyone can easily create a trial account. In this chapter of the demo, we are going to discuss how you can create a Cumulocity IoT trial account easy and fast. You will also see how easy you can connect your smartphone. The steps we are going through will be how to create a trial account and how to connect your devices, in this example your smartphone, with your newly created tenant. This is the product page of the Cumulocity. You see on the upper right corner the Try for Free button. If you click on that, it will open a new tab where you have to enter some data. You see it does not require complicated or too much information to register. Only the most necessary is asked. Besides your name and your email address, you decide what cloud region you want to use and give your tenant an own name. If you click on the Sign Up button, after just a few seconds you will be the owner of your new tenant. It is a very easy and short registration for everyone. Go to the login page and enter your tenant name. If you click on Next, you have to provide your username and your password. And here you see your Cumulocity trial. Just click on Open, and here it is, your own tenant. So what we're going to show you next is how you connect your smartphone. And therefore, you can click on Connect Smartphone, which opens a wizard that guides you through the process. This is also very simple and required only 2 steps. First of all, you have to install the Cloud Sensor app on your phone from the Google Play Store or the Apple Store. Open the app on your smartphone and scan the provided QR code. And now you're done. Especially for testing the Cumulocity, this is very helpful. Now you see the dashboard, which leads you to the next chapter. But first summarize what we've seen so far. We showed you how easy and short the registration process for your own tenant was. There was no complicated registration process, and after just a few moments you were able to log into your own tenant. We also showed how easy it was to connect your smartphone with just scanning a QR code. With the Cumulocity, everyone can create an own dashboard. So here's the situation. The end customer wants to see the actual status of his machine. He wants that independent on his personal location wherever he is at any time. So let's take a look on how a customized dashboard can be created. You will basically see two steps. First, we create an empty dashboard. Secondly, we will place widgets via drag and drop and customize them. In the last chapter, we already mentioned the dashboard. Now we want to create an additional dashboard. This is an example, and we want to show you how easy this can be built up. Here on the big plus, a wizard opens that guides you through the creation process step by step. You can enter names such as dashboard demo and change themes and layout if wanted. Now we do have a blank dashboard that wants to be filled. For that, we have many different widgets that can easily be used. On Add Widgets, a preview of all templates opens. In here you see widgets as lists, table, graphs, and others. Let us start with a simply data point graph. We choose the data points and save the widget. For this example, we choose the air pressure. For a more advanced visualization, we can use the SCADA widget. In here, we upload a SCADA graphic. The placeholders can now be filled with any value that I want, so for example, a name, an idea, or a measurement. In here, I choose wish measurement, and we will see a preview. What's missing is a gout widget. In this gout widget, we choose the data point and see it here. Last but not least, we want an alarm list. So let's place a list of all active alarms. And that's it. We are done. After we create all these widgets, we can also edit them. We added the gout widget so we can set critical alarms. We just have to expand here and set here the alarms for yellow and red range. And save. That's it. Since the dashboard itself helps to gain transparency, your end customer probably also wants to create own rules for alarms, which brings us to the next chapter. Let's summarize what we have seen so far. We created an empty dashboard. We filled that just via drag and drop and without coding with some widgets. With the Cumulocity, everyone can create powerful analytic rules without coding. The next topic will be streaming analytics. But first, what is streaming analytics for us? It is not making decisions about the past or about the future. It's making decisions about right now. Creating these rules usually based on coding. But most of the operators don't have deep coding skills, but are very experienced and can actually tell you whether the current production or process is good or not, based on their knowledge. A big benefit for these domain experts would be if they can create their own analytic rules with predefined function blocks. Here is what we show you. We will open the streaming analytics application and create new rule. The rule should trigger an alarm if we shake the phone too much. For that, we will drag and drop function blocks into our application. We will see the raise alarm on the dashboard that we created previously. We open the Streaming Analytics application here on the App Switcher. Next, open the Analytics Builder. In here, we will create a new analytics model. We can give a name and some description. Currently, the rule is empty. On the left side here are well-organized all-connected devices and many powerful functions as creating an average or a gradient, or for example, the difference between two values. So let's start with our rule. We drag our phone from the left to the main window here from the input. Here we can choose between all measurements that are provided by the phone, for example, acceleration. If we shake the phone, the acceleration rises, so we need a threshold. The threshold is under the calculation. We want this block to activate it if the acceleration is above, for example, 0.5. What should be the result? We want an alarm, so we drag the phone here from the output and tell the block to create an alarm if activated. Let's enter some text. Connect the lines from the input to the threshold and from the threshold to the output. And that's it. We just created our first rule. That's simple. I opened the dashboard from the previous chapter. So here you can see that there is currently no shaking alarm. If I shake the phone now, you will see that alarm arises. You just saw our non-coding environment for creating powerful analytic rules. By giving your end customers the possibility to create their own streaming flows for their devices, you can bring them a big benefit, for example, to supervise a production process.
With the Cumulocity, everyone can build up a simple data pipeline. Data is the new gold. A machine operator wants to know in advance if the machine breaks or requires service. A product manager wants to analyze the behavior of the usage of their products in the field. However, in order to be able to extract value out of the generated data, it is important that data is structured and can be queried from within various tools. So, first things first. We will show you how the necessary pre-work for a data pipeline from IoT devices can be achieved within the Cumulocity IoT platform, nice and easy. Let's take a look on how historic data can be easily offloaded to a data lake system and be used from other tools such as Python or Power BI. We will create an offloading configuration that pushes data to a configured data lake system. After that, we show you how to create a Power BI dashboard based on this data. We will also extract data from a Python code that can be used to enable machine learning processes, which will especially be interesting in the next chapter. Here on the left side, we see some of the steps that are needed in order to create a data pipeline. So in the settings screen, this is something I already prepared. So here is basically the connection to our data lake system. So in this example, it's an S3 bucket, but it could also be an Azure Data Lake or another local file system in an on-premises installation. If I click on the offloading here, we will come to the section where our wizard guides you through the necessary steps that are needed in order to offload data to this configured data lake system. So if I click on offload collection, you will see all the necessary steps in here that are needed. So for example, I define which type of collections or which type of data should be offloaded. So should it be either an alarm, or should it be the events, or also the measurements? So for example, the acceleration measurements we saw. So if I define alarms, then it will go to the next steps where it asks me basically whether I want to change the target table name or whether I want to add additional results into the column. So, and you basically see to every step some explanation in here, but also some examples. So what additional parameters could be you can enter in here. On the next point, it also asks you whether you want to filter, so meaning whether some additional alarms should be excluded. So like, for example, all critical alarms or alarms that have been cleared. And in every step, you can easily validate whether this is a valid input you put in here. Can now give the offloading task a name and a description in order to remember it afterwards. Here you will see the summary of our collection task. So meaning it shows us the defined names and what type of collection it's offloading, but also how often it is doing. So for example, here every hour. It will also show me an offloading preview in here. So I can activate it now. And if I save it, the job runs automatically in the background. And I will see it here, besides the other collections I might define in the future. So the Data Hub actually allows you also to query the data that is inside the data lake. And here we use standards like ODBC or JDBC or REST. So any application that is able to query data via these protocols can be used to get the data from the data lake. I will show you two examples today. So the first one is actually Power BI, since this is a very often used application in terms of reporting. Inside Power BI, there is a standard connector that can be found if you click on Get Data. Here Wizard opens where you only have to pick the connector of choice. So in this case, it's Dremio, the powerful engine behind the Data Hub. If I click on Connect, the Dremio cluster only asks for the URL where my data lake is running. So I enter here the URL together with a port and click on OK. In the background, Power BI is now collecting all the data from the data lake. So, for example, in here, all alarms or all accelerations I was saving on the data lake. I click on Load, all the data will be put into the application so that I can use it for different type of reportings. All the data is now here in the fields section. I can now drag and drop them just here into the middle part. So for example, the acceleration in X, as well as the acceleration in Y or in Z. I can also create some scatter plots. So for example, the acceleration in Y, not summarized, against the acceleration in Z, against the acceleration in Z, not summarized. In that way, I can create powerful reports that can be used to dive into the data in the data lake. Another application is actually more data science related. So the data scientists out there in the world usually use Python, R, Jupyter Nodes, so more programming languages in order to query data and find insights there. So what I will show you here and what I provided is just a little Python script that connects to the data lake via the data hub and queries, in this example, acceleration data in X from this data lake system and builds up a histogram. So if I start the script, it gets the data, puts it in the bins, and then will show in here, for example, the distribution of the acceleration in X, which can then be used together with other data and other libraries to create more insights about the data in the data lake. And due to the freedom of the ODBC, JDBC, and REST connectivity of the data hub, you can use actually any application that is capable of doing that, which gives you a lot of freedom on the applications you want to use. The Cumulocity helps you by structuring all your IoT data such that you have an easy-to-use data pipeline. You can easily connect many tools of choice in order to gain insights about your data. This will enable many interesting use cases, for example, predictive maintenance, which brings real value to end customer side. With the Cumulocity, everyone can start machine learning. Use cases such as predictive maintenance and others do gain production efficiency and therefore are very interesting for many end customers. Together with the historic data stored in the data lake system, we perform the first machine learning steps. The application will guide you through the necessary data science steps that are needed. Let's take a look on how the Cumulocity platform enables you to perform easily your first data science steps. We will create a new project within the machine learning workbench, our data science application. We will extract data from the data lake that was previously filled. We create our first model with the AutoML wizard, which guides you through all the steps. And we will use that model in a rule in order to predict the upcoming data. This is our machine learning workbench. What you will find in here are the projects where you can cluster all the different machine learning and data science projects you want to do. It is initially empty, so what we will do at first, we will add a new project. We give it a name. And a description. So what you see in here now is our demo project. If we open that, you will see different folder structures. So meaning directories in which all the different types of information we cluster are orchestrated or filtered. Meaning in data, there is data. In code, there is code, such as Jupyter Nodes, for example. In models are models, etc. And in this way, you have a very nice and clean structure how to work. So what do we need for machine learning? We need actually data. So let's add a resource. And the resource in this scenario is now from the data hub, meaning we have the possibility in here to query data from the data hub. So meaning, for example, acceleration data from the previous section. So what we do here as a use case is now we query the acceleration data in Z, X, and Y, but also the raised alarms and their majority, and put them into the machine learning workbench. So if I submit here and give the resource a name, put in here demo, then we will see our task history, which says pulling data from the data hub, currently in the state running, and in a second the status is completed. So where we will find the data now? We will find the data now in the data section. So meaning in here is now a CSV file that contains the acceleration in Z, Y, X, but also the maturity of the alarms. What I want to show you now is not how you could do it, for example, with Jupyter nodes in the code section. I want to show you an easy approach. And this is our AutoML functionality. If I click on that, I will be guided through the different steps that are needed, for example, to have a classification problem. So I will see that there are values in the different types of acceleration. I want to use them for the model. I don't want to use the creation time, but I want to use the severity of my alarm as the target variable. So what I'm doing here is I'm using the information of the acceleration in Z, Y, and X to later on predict an alarm. If I click on build, it asks me basically informations about my model. So meaning we call it shaking model in here. It asks me about what I want to use of scoring. So let's put in here an accuracy. And it asks me what types of algorithm I want to use. And if I'm not sure which one, I basically do select all, and then the application itself finds out which one is the best. If I click on submit, we are back in the tasks, meaning the training started now. We also see some task informations here on the right. And depending on how much data and how complex the model is, this might take from seconds to minutes, probably hours. So since the acceleration data we are using here for the model are rather small, the training of this model might just take a few seconds. So the status is completed now. And you also see the message here that the model was saved to the model section. So if I go back to my project, I see that here's now my shaking model in terms of a PMML, which is in machine learning a standard. So this PMML now can be used to be deployed in the runtime engine of the Cumulocity IoT platform. So what I do is I basically click here on the little cloud, which means deploy. If I click on that, I will see the notification that this model was deployed to the server. So how can I use this machine learning model now with live data coming into the Cumulocity IoT platform? Do you remember my alarm smartphone flow in the analytics builder? So what we did here was actually we used acceleration data in one direction, so meaning in Z. We applied a threshold of 0.5, and if this threshold was exceeded, then alarm was raised. So we want to do this more based on the training we just did on the machine learning workbench, but also not using just one direction, but all three directions, so X, Y, and Z. So let's remove the threshold block. So what we do have for that is a machine learning block. So this machine learning block has the possibility to use the previously trained shaking model as an input. And if you remember from the training, as an input, we had the accelerations in Z, but also we had the accelerations in Y and in X. So those are actually now the inputs. So meaning I just combine here the dots, and as a target variable, we had the alarm, which is now triggering the creation of an alarm on the alarm block. And with this, we combine now streaming data, so the accelerations coming from the smartphone that are used in the machine learning block of the shaking PMML that creates an alarm whenever the trained model gives the output that an alarm should be raised. We showed you an easy-to-use application to guide you through the first steps of machine learning and data science that is directly connected to all IoT devices. The end-to-end approach between connectivity of devices and machine learning creates a simple user journey. With the Cumulocity, everyone can integrate data from various systems. In real-world scenarios are many third-party systems such as ERP, MES, and others. And integration from and into those systems can give a lot more insights and thus accelerates many use cases. Let's take a look on how our self-service integration tool can be used to combine the IoT platform with a ticketing system and an SAP ERP system. We will create a new workflow. We connect our Cumulocity IoT platform we are using. We connect a ticket system. We will connect an SAP system. And we will combine those systems to an overall workflow. So when we shake the phone, a ticket in the ticketing system will be generated together with the customer data from an SAP system. This is our self-service tool webmethods.io. And within here, I can create powerful workflows that combines several systems. So in this case, we want to start with an alarm that is raised on the Cumulocity IoT platform. And therefore, we have the concept of triggers. So when I go in the start block and go into the settings, it asks me what should be the trigger for this flow. So meaning, when does the flow should start? It could be like anything, like it could be clocked, so every hour, it could be a webhook, it could also be an MQTT message or a WebEx meeting, but in this scenario, it will be a Cumulocity own trigger. So meaning an alarm, for example. So every time an alarm on the platform is triggered, this workflow should start. I'll connect it to my Cumulocity IoT instance and put in here the device ID from my phone. I can test this now in here. So I could do a test on this trigger, but I'm skipping this. And then it shows me basically how the action looks like, and I can save that. So every time now I shake my phone too much and the alarm is raised, this workflow is initialized. The next thing I want to do is I want to connect it to an SAP system. So in this scenario, we are using an SAP S/4HANA Cloud. So again, I can put in here with the settings tag, and I can select an action. And in this case, it makes sense to actually read the purchase order of this inside the SAP. So meaning I connect this to my SAP Cloud and I look up the purchase order from this particular phone. So meaning I go into the trigger data alarm here and I can query through the messages now. So meaning every alarm has a source and a source ID And since this ID of my phone is combined to the purchase order, I can use this as a filter what purchase order I want from the SAP system. Again, the action is shown here as an example, and I'm done. So every time now an alarm is raised because my phone was shaken too much, the purchase order of this phone was read out from the SAP system. Now I want to create a Jira ticket because the phone was shaken too much actually. Again, I can click on settings. Then it will ask me again what type of action I want to apply on Jira. And in this scenario, we want to create an issue. I can connect it to my Jira instance. And on next, I can fill in now all the necessary informations for an issue. So I can read this out from my purchase order. So meaning this could be, for example, an address name in the description. This could also be an purchase order in the summary, and it could also be, for example, from the alarm section, the text in the project key, and probably the severity as a priority. If I click on Next, and we're done. So now every time my phone was shaken, the purchase order of this phone is read out from the SAP system and is guided through Jira that creates an issue based on the purchase order data and the alarm data in Jira. If I put into the stop log now, my workflow is done. And with this, I combined several systems down from connectivity of the devices over other systems like ERP or ticketing systems to provide an overall user journey. You just saw how our self-service integration tool increased the transparency while connecting to and from other third-party tools. You saw how easy and fast your own trial was generated and your first device connected in the first chapter of Start a Connected Trial. After that, we demonstrated how you created your own dashboard via drag and drop. A non-coding application for creating powerful analytics rules helped us to trigger an alarm. Since analyzing historic data is very important, we showed you how an easy-to-use data pipeline can be built up to gain many insights. We guided you through a simple training process for your first machine learning steps. And last but not least, we demonstrated our self-service integration to get a more cross-functional view.
Don't just take this from us. Let us show you what Magnation says about us. They analyzed Software AG and 10 other IoT solution providers and rated Software AG as the leading IoT edge provider with the highest score for edge data processing and edge management. Let's come back to our initial picture. You probably have not multiple devices anymore. Can you remember living without a smartphone? Same will be true for an IoT platform. The people using their current IT landscape will benefit from an IoT platform. This will result in more transparency, less failure rate, and faster processes. The Cumulocity IoT platform enables you for fast and easy entry. Feel free to start with a Cumulocity trial in Tenant to connect your first devices, and we are happy to assist.